I'd like to introduce Gareth Davis. He's our manager of innovation and digital solutions with Bechtel, and he is on CII's technology committee and has been helping to organize some of these great webinars for us. So I'll let him introduce this team to you today, and I'll thank you all again for joining us.
Good morning, good afternoon, everyone, or good night, wherever you are. As Jenny said, I'm also the chair for our Horizon 360 subcommittee of our technology committee, which is the ones who have put together these webinars. Our Horizon 360 subcommittee seeks to identify new technology based solutions and innovative practices that we can implement that are also cost effective to our member companies and CII. Today, our esteemed panelists will be sharing their perspectives regarding robotics, photogrammetry, and data processing automation that enhance and streamline the data flows in the projects that we do today and provide enhanced visualizations to all of the stakeholders that contribute to executing construction projects around the world. We have these solutions that whether the solution is targeted to do progress monitoring, installation accuracy, or identify risk and safety. These are all great solutions that we will be discussing in a conversation today. Our main facilitator is Jim Yanosick, who I'll be introducing today, who will introduce the rest of our panelists. Jim?
Yeah, thanks, Gareth. As Gareth mentioned, Jim Yanosick, I'm the Director of Client Relations here with iBot. And so I'm very pleased to be joined by Dmitry Gurevich from Shell, Keaton Denzer from Bechtel, and Jake Lydick, our CEO and founder of iBot. So I will have each of them expand upon some of their experience and value of reality capture as we move through the webinar. But first, we wanted to just have a few quick poll questions to get a better understanding of who's in attendance and how you may be applying some of this technology. So our first poll question, I believe it's launching now. So reality capture and drones and robotics tend to go hand in hand. So wanting to get a better understanding of how, if people are using drones and robotics on their projects. So we'll just give it a few seconds here for everybody to vote. Looks like we have about 50% in right now. So right now we're about 70% voted. So we'll give that just a few more seconds here. 76%. So I'm not sure if it will show us the results. So I will go ahead, give it just 10 more seconds. That will have been 1 minute. We're at 77% voted. Right now, we are at 63% yes and 37% no. So we'll go ahead and close that poll. So a lot of the topics today will have to do with drones and robotics. So for those of you that are using them, hopefully we can provide some additional insight. And for those of you who are not, hopefully that will teach you a few additional things about how you could leverage them. So our next question is for that 63% of people who do use robotics. So if you are using robotics or drones, how are you using them today? Video imagery, always the standard. I think I've had some time on sites, and it's always fun when somebody comes up and it's like, oh, I have a drone, or my kid has a drone, and it's typically for those video and imagery type things, and so it'll be interesting to see how others may be using them beyond that. And so we're just at about 50% here. We'll just give it a few more seconds. And we'll go ahead and close this one. And so we are at 93% using video and imagery, 52% for mapping and modeling, 43% for progress monitoring, 7% for emergency response, and 13% for inventory management. So our last question is for those who maybe haven't used drones and robotics. And so that is, if you have not, what reasoning for not implementing, those types of solutions. So we'll go ahead and just give a few more seconds here to vote. %, here. So looks like about 50% of answers are due to budgetary constraints, about 40% lack of subject matter knowledge, 27% not decision maker, 22% regulatory compliance, and 20% change management. So again, very much appreciate everybody sharing those responses with us. I think, the panelists here today will be able to share a lot of very insightful information for us to maybe help you make better decisions about, costs and, just the knowledge of how this type of technology can be leveraged. So without further ado, as the title of the webinar states, our goal here is to discuss advancements in reality capture today. But I think before we do that, it's important to highlight, how reality capture is being used today. So I want to first hand it over to Dmitry to tell us a bit more about his experience as an owner on the owner-operator side, and share with us everything that he has learned during his time. So Dmitry.
Thanks, Jim, and hello, everybody. My name is Dmitry Gurevich. I'm with Shell based in Houston, and really this is just a conversation starter. I don't have all the answers, but I would like to introduce our recently completed Pennsylvania Chemicals project, really just to get us going on the topic. So the Penken site, Jim, if you can just go back for a second, yeah? The site is located about 35 miles from downtown Pittsburgh. The project was sanctioned in 2016 and went into production in 2022. So we delivered it through COVID with the help of reality capture. It comprises of an ethane cracker and 3 product manufacturing trains. So it's a pretty large manufacturing site. And at the peak of the construction phase, we peaked at roughly 9,000 workers active at the job site every day. So I used to lead the information management and digital team from the Shell side on the project. And we work closely with our execution partners such as Bechtel and the technology partners like iBot to come up with products and solutions that would help us keep people who work at site both safe as well as productive. So we can go to the next slide, please. Just a few words about our approach. And the big question why, and kind of what kind of problem are we trying to solve here, right? So we started after realizing that we needed to create a better visibility into what was going on at the job site amid a pretty small owners team. So it was really about creating the visibility and creating greater reach for the people who managed the site and managed to work at the site. Amid the challenge, kind of the scale of the challenge that was in front of us. So, but once the visibility challenge was solved, we quickly realized that just providing visibility wasn't enough, or at least the level, the expectation lever shifted, and people wanted tools that help them measure progress, help them measure things, and to become a bit more data-driven in the decision making. So we moved from seeing to measuring, and then the final step was really trying to understand how can we use the data, the knowledge that we accumulated to inform decisions kind of looking forward, right? So it was a shift from looking backwards to kind of trying to see what we know about the past that informs the future. So the guiding principle for us was, the see, measure, preempt, or predict, or anticipate and preempt something, for a better outcome. You go to the next slide, Jim, please. We didn't arrive to reality capture overnight, okay? And I know today we talk about reality capture as the solution for a lot of challenges, but looking even at this one project, we started with using satellite imagery during the location scouting back 10, 11 years ago. Then during the early works phase, 2014, 2016, we used to fly an aircraft over the construction site, take photos, high resolution photos. And at that time, that was, the best we could come up with. But then in 2017, the drone kind of theme started to gain traction in the industry. And really, there wasn't a lot of, at least that we knew about, there wasn't a lot of knowledge. So we really tried to experiment. We started experimenting with this new technology. And it sort of coincided with the project breaking the ground and the start of the main works construction phase. So next slide, please. So in a nutshell, right, this experimentation eventually led to an extensive drone program and a broader reality capture program using, cameras and laser scanners and drones that sort of evolved with the project. The needs of the project continued to evolve. So it was never static, and we had to kind of develop in step with that and hopefully develop in anticipation to stay a little bit ahead of the needs of the construction team. So at the peak, we ran the surveys weekly, right? We developed both 2D products as well as 3D products, and we use them in different ways. But the important thing is that all the data was always considered to be a single source of truth for everybody. It wasn't withheld and kept against anybody ever. It was always shared to provide kind of this plain level field objective view of where the project is at any point in time. Next slide, please. So just illustrate a couple of examples. Again, just a couple of quick things to show how this model, how this content, this media was used on the project. This is probably the easiest thing to talk about. This is A to B compare type thing. This is two captures compared side by side, taken, I think, 1.5 years apart in this case, a pretty extreme comparison. How was this useful? Once people realized that the progress of the construction itself, kind of as it happens, is getting captured, we realized that being able to go back in time and discover how the site conditions were at a given point in time, be it in a performance conversation with a contractor or subcontractor, or just to understand the trend, how things were evolving, proved to be very powerful. Right, next slide, please. The previous example was your basic C example, right? There is no measurement there. It is just visual comparison of how things were then and now. Versus to this use case, which is your traditional volumetrics, right? This is us trying to keep track and stay on top of the backfill volumes amid a very constrained environment of a very congested site. We had to be very purposeful about, what space we use for what and how much backfill material we have to move and how much we have surplus, right? So being able to take those measurements week on week, accurately and safely, because we did no longer need to send surveyors in the field, was a very good productivity enabler. Next slide, please. So in this one is just an illustration of this plan and anticipate example, if you like. So what you see here is a snapshot of the so-called site master plan that was created and managed by Bechtel, the site manager and the main works contractor. And this was a use case basically to plan again, the congested real estate in a way that makes sense today, but also prepares the project for tomorrow, right? Because these needs change constantly, be it your laydown material space, be it your module staging space, be it your column dressing, or if you are planning for safety and you need to check whether your master points are still in the logical places, where the pathways are safe, whether you know the water drop-off points are in the right place and stuff like that. So all of that, doing it against the actual picture, the actualized view of the construction site, again, was very powerful. So finally, maybe just to pause here and really drive the point about safety, okay? So standing up a drone program, and actually came through the poll even, right? I mean, I cannot really emphasize this enough, that this is a learning curve, okay? And it was a learning curve and a trust building curve for us as the team that led the program and everybody else who worked at the site, okay? Back then, drones were novel, again, novel at least to us. So we had to pull in the experts from our own, you know, in-house aircraft logistics teams, the industry, the technology partners, you know, anybody we could find who knew how to do things safely to arrive to this initial view of how to do this, okay? In the context of this particular site, how do you start a program like that? But it is never static because your site always changes and your needs always develop. And you have to kind of keep back and keep making sure that what you do still makes sense. It doesn't expose people to risk, and it delivers on the objective that you set, yeah, from the quantum perspective. So I know we'll talk more about safety today. I think that's probably kind of, I'd like to draw a line here and hand over back to Jim. Thank you.
Yeah, thanks, Dmitry. You know, really great insight there about the use throughout the project. So now I'd like to turn it over to Keaton and have him explain a little bit more about how Bechtel is leveraging reality capture currently.
Great, thanks, Jim. Hello, everyone. My name is Keaton Denzer, and just making sure everyone can hear me all right. Excellent. Awesome. So I run the drone program for Bechtel. My official title is the Chief UAS Pilot. So I'm in charge of making sure not only that we're using this technology, but that we're using it in a safe and effective manner. Of course, you just heard from Dmitry about several aspects that are extremely important when considering running a program like this. And the two key parts are we're working on an extremely dynamic and large scale projects, doing a variety of work. And because of that, all these things moving, all these things changing, it is very difficult to very easily bring on these robotics, bring on these new technologies and use them in a safe manner to ensure that we're not running into things or having any issues with people on the ground while the robotics are moving around. And so, you know, in developing programs like that, it's very important, of course, to work with the team, look at the variety of technologies and use the right technology for the task. So what you see here on this slide is really the three, what we consider the basics of reality capture, the three ways that we're truly digitizing our projects. Starting on the left from our least quantitative, so more of your qualitative visualization using 360-degree imagery and video. There's a lot of amazing technologies out there at this point that what they call it is X-ray vision. They essentially give you a see-through view, a change over time, so that in the event of things changing, you can go back in time and see through the walls, right? See where things were built. You're able to compare it to your 3D models. A lot of very interesting work being able to line up these immersive realities in 360 to our reality, both the model and the actual job site as it evolves. Next is the photogrammetry, which really is the origins of everything that we're doing in reality capture. Dmitry mentioned that in 2017 is when it really grabbed hold and we were truly able to, you know, the technology had evolved enough where we could consistently, effectively, and safely fly a drone, document, capture the site in a consistent and high quality manner that we could then generate high resolution, accurate 3D models that not only were pretty pictures, but now we're three-dimensional in aspects, so that we could not only just see and plan where our workers were going to be, but exactly how much they needed to do, right? This is when we're beginning to bring in the quantitative analytics, being able to count things, being to do volumetrics and linear measurements and area measurements, which really is what starts bringing in the value of what we're doing with reality capture. Then, of course, being able to compare to three-dimensional models and everything of that sort, and again, in a quantitative manner, being able to address exactly how much needs to be added, removed, changed. Then, of course, the even more in-depth, the more technical, and the highest accuracies and resolution you're going to find is once you start really stepping into the LiDAR world, both terrestrial and aerial LiDAR, because, of course, on the ground's never enough, and we need to put it above these objects that we're needing to visualize vertically. And for those of you who have worked a lot with photogrammetry, we discovered there is a variety of limitations when it comes to being able to see vertical objects in high resolution. So scanning really bridges that gap and allows us to create three-dimensional models, again, high resolution, in our own coordinate systems, that we can see the details. As you can see in this image, you can see the size of the piping, you can see the height of everything. And of course, with the rise in robotics, this is able to be put on drones, it can be walked around, it can be put on vehicles, and everything of that sort, allowing us to create these models that can then be compared to our designs and allow us to do not only qualitative, but quantitative work. You can go ahead and go to the next slide.
Great. Yeah, so, what I'd like to do now, and I really appreciate the insight from both, is to just, sort of do a roundtable, ask a few different questions to you each. We'll highlight, sort of the value of reality capture a bit more. So, Dmitry, when we were going through this, safety was obviously something that continued to come up. So, can you share a bit more about how you were able to use drones in reality capture to, really enhance the safety of the Pennsylvania Chemicals project?
Jim, thank you. I'll use two examples. One is kind of digging back on what I was showing just a couple of minutes ago. Our safety team, the joint safety management team that overlooked the operation of a large construction site, they used these reality models extensively for work planning, right? To make sure that the work was planned safe and the site was still efficient in its configuration. And again, during a work phase, when you're at the peak of construction, things make, so giving them the canvas, that represents the actual kind of physical, condition of the construction site, giving them consistently and predictably that they can trust it, was very helpful and made us more accurate in our planning, and it made us more accurate in our predictions. It made us more accurate in again, the ability to anticipate and prevent things from happening, by just getting better prepared. So that's the first example. The second example is when the COVID hit, right? We had to temporarily suspend work at the site, and everybody had to go, basically had to leave, right? So at that time, right, we were at the peak of our activity, and the challenge was, you left a large construction site with a lot of work that was mid-flight, midway through execution. We needed to make sure that the work was shut down safely, right? So having the capability at that time with the drone program already in place, basically allowed us to pivot, to a very special use case and make sure that we inspected all the platforms, at elevation for any loose material. We inspected all the egress, egress points in confined spaces that they, again, were not exposed to atmosphere. We were able to dispatch teams and kind of close things down, shut down safely. So that was new, right? It was unexpected benefit, but it was timely and super helpful at the time.
Oh, that's great. So Keaton, from what you had discussed earlier, there's a lot of different reality capture technology. From an EPC perspective, where have you seen the most value in implementing reality capture, throughout the life of a project?
It's a really interesting question to ask for what was the most valuable aspect, because each level, each phase of the project, I believe that there's a different technology that brings the best value, but I do believe all of them are important to be used together to create the true, highest value quality data that can benefit all aspects of the project through all the phases. So of course, looking at something like pre-documentation, being able to keep our guys and of course, touching like on Dmitry's safety point, being able to visualize an entire site without having to send crews into an unknown area. Many of our projects are along the coast, very swampy with alligators and snakes. Being able to fly something like a drone over an area to capture the photogrammetry, and then LiDAR to be able to document the ground without the vegetation, without having to send a surveyor into the brush for weeks or months to be able to document it is amazing value, to be able not only keep them safe, but to be able to capture high quality, even higher quality, by using the photogrammetry aspects of drones and LiDAR. And then moving into earthworks, moving massive amounts of earthwork quantities. Many of us have heard and worked with machine control, which is fantastic in what it can calculate and look at your daily values. But being able to quantify your weekly, monthly, and yearly earthworks as you're moving as much earth as we do on these projects, it's tremendously important that we're using drones to be able to pull our volumetrics and create 3D models to compare to our CAD drawings, because in the end, the only way to track exactly how we are on schedule is by quantifying using something like drones, where we can see these high levels of accuracy and low levels of estimation or shifting the numbers. And the redundancy, of course, is extremely valuable with the earthworks as well. And once we get into the field construction aspect, it really is a combination of all three. Although I do believe with up and coming technologies, something like SLAM LiDAR, allowing us to document the vertical aspects of our project in a higher detail than we've ever seen in the past, in a safer manner, where we can, from a distance, be able to walk around an area that's being worked on and be able to model out and then check what we just scanned in comparison to the designed model. There's a lot of value in being able to do that than in the traditional methods. And then, of course, handover. We've had so many clients come through recently seeing these technologies and be like, you're capturing all this data, this high quality data that helps you when you built it, and now we're going to come in, right? We built it, now the client's going to come in and have to work it. They're going to want to see every aspect of what we built and not have to start from scratch. So for us to be able to have these in-depth illustrations and models of everything that was constructed really opens, gives visibility to what we've done and what they need, so they can go in and see. So in the event of there being any issues or everything's working well, they can go in and see what we did. And there's a lot of benefit being able to not have to start over and have all the models from as we built from day one.
Oh, those are great. Really appreciate the insight and sort of the different phases and how it's used. And so I think, with most technology, there's always the things that you go in expecting, but then there's always sort of your sort of unexpected or, sort of your hidden benefits of reality capture. And so, Jake, I'm gonna loop you in here because, you're seen climbing a ladder here on this image of the right. Can you, maybe share a bit more about, what you were doing in support of the construction and, how it provided, safety and value to the project?
Yeah, sure. So I'm Jake Lydick. My official title is CEO, but anybody that knows me knows that I'm just the director of delusional optimism for my organization. You can see 3 points of contact on that ladder, and I'll take full credit for the constant safety minded. Obviously, that we view ourselves as technicians, and when we get these these different challenges, in this instance, there was I think that we're inside a HRSG, and there was a burner alignments that they wanted to monitor, and people knew what technology that we had available, at the time, and that it may or may not be something that they could, run an interior inspection of the burner alignments. And it turned out that we configured a drone solution, for that specifically, and we're able to deliver, multiple different people, high resolution imagery of the burner alignments inside a, 6 or 7 story, interior space, instead of having to build scaffolding in there to manually, observe them, at arm's reach. So just an example of where, being able to, leverage a technology solution can help people stay out of areas like that. And then the cost savings, obviously, with just the scaffolding alone, in that single instance, pretty interesting.
Yeah, and if I remember correctly, this was prior to the collision tolerant drones, and I think you had to fly everything manually, which just that in itself, if anyone's ever flown like an FPV drone, it's quite the challenge. So props to you on handling that and keeping everything safe. So, with that said, value in technology, also comes with challenges. And so I wanted to just, take a minute to expand upon a few of the challenges, with the panelists here. So, sort of sticking with, Jake, when you started this project, I believe it was 2017, technology, as both Dmitry and Keaton had mentioned, was still very new. How did you manage the scale of the project in implementing, some of the challenges that you had to overcome to scale on a project of this size?
So we had the core competencies of the data capture and the data processing established when we started the project. It might have been some of the reason that Dmitry wanted to work with us, but when we really looked at wanting to leverage high fidelity 2D and 3D data across the entire facility, the scale of the project was really the primary challenge. That was the biggest challenge from a capture perspective. The weather changes and even the site evolving underneath you as the technology that was available at the time. One drone couldn't capture it in the window that we had available to us. We wanted to fly the drones in a time that there was minimal site presence, but it went 6 days a week a lot of times. So we did our captures on Sunday. And what we ended up having to do is geofence 2 simultaneous captures with synchronized camera settings, overlaps in autonomous operation that was synchronized with visual observers at each post. So that was at the time how we handled the capture scale. From a data processing standpoint, the data requirements really, everything that we put that much imagery into at once in order to turn around the data, where it was apparent that every moment past the time that the data was captured, the data had less value. So the turnaround times needed to be, very fast. So everything that we threw it at the time, it broke. there wasn't a lot of tools that were available to us. So we had a partner that helped us with this is enterprise data processing. We were able to break the data down and process segments of it, and then, reestablish the data for continuous, end-to-end piece of information that that met the requirements. So that introduced the challenge again in making sure that you didn't degrade the quality or the time in doing that. So those are a couple examples of how we tackled the scale, in which was definitely the biggest challenge. There's a lot of the software that we were working with at the time also didn't have built-out APIs like the software does now. So a lot of the the integrations and the uploads into the other systems that this data needed to exist in had to be done manually. But the communication between the teams, collaboration, a little bit of trust, some creativity, and some problem solving allowed us to get a pretty good workflow and continuously improve those processes as we went.
Yeah. What did you say an average capture was? About how many images?
I think that the 2D orthomosaic captures, I believe they were around 10,000 images, and the 3D ranged. I think that there could be an additional 5,000 or 6,000 on top of that to be able to get the oblique imagery to generate the 3D product that met the requirements of the.
Yeah, so 15,000 images or so. Dmitry, I think you mentioned earlier there was 120 surveys done throughout. From an owner-operator perspective, Dmitry, and the data management task there, and the just vast amounts. How did you, face, like, what challenges did you face in implementing this type of data, on a project of this scale?
Thanks, Jim. Maybe can you hear me okay? To change my headset.
Yes.
Yeah. Again, maybe I would like to start with the end in mind. So the goal was to give everybody the same plane level fields, irrespective of whether they worked for Shell, for Bechtel, or a subcontractor. So we had at the peak, I believe, more than 2,000 users to serve, right, with different media formats. So understanding what media format, how do people want to consume this information? What is their use case? What are they basically doing with it, right? It didn't appear overnight, okay? Again, it developed with the project, but what really enabled to sort of, what really was an anchor point for us was to be able to do that through cloud, okay? 80–90% of all consumption, of all kind of value extracted from the server program came through a shared cloud solution that was accessible to people in the trailer, in the back office, or at the construction site. So landing on something that is so ubiquitous, that can be so ubiquitous, right, accessible, free to use, yeah, from the user perspective, easy to get to, was very powerful. The second I think enabler was that even today, yeah, Keaton mentioned many different modalities of how you can do reality capture. Again, we focus on drones, but there is a lot of content that can be generated with SLAM, 360 photogrammetry, or just basic photos that people take as they walk about the site and they want to share it with somebody. So, or static cameras, time-lapse cameras. Well, again, for us, the strategy was that we want to bridge all of this content in the same screen, right? So again, having a cloud platform that enables people to see everything in one place, as opposed to managing 10 different usernames and passwords, that sort of thinking was very important. Yeah, important to get right. And then, as you kind of get more and more into the process, you realize that, yeah, people like to consume data in different ways. Some people need to see it on the web, but some people want to have the orthophoto, overlaid with your site layout, printed and placed on wall, right, where they can actually walk up to, right, and write something on it, okay? And sometimes Smartboard doesn't cut it. So even the pipeline, the content development pipeline that takes the ortho, brings it into the CAD drawing, overlays that, date stamps it, adds a revision, and then distributes to people who need it, and then, print for some people. That all takes time, okay? And again, you don't have to have a solution for that on day one, but you need to have a solution eventually, and hopefully before it becomes overdue, right? So again, just thinking of how to distribute the content, who consumes it, and what are the most impactful, most common and useful ways for you to deliver it, and then figuring out how you deliver it on frequency. How do you shorten the capture time? How you shorten the processing time? How do you basically make it predictable? That was the biggest challenge.
Yeah, props to you on managing that. I know that there was not really a standard operating procedure for that. So kudos to you for seeing that and implementing that along with your team and everybody else that was involved. So, Keaton, wanted to kind of turn it over to you to expand, maybe a little bit, of a similar message that I think you share with Dmitry on, how this type of data, there's so much of it, right? And, from an EPC perspective, you probably have various subcontractors that are scanning, and how you manage that incoming information. What challenges do you see in, managing all of this information?
Yeah, Jim, Jake and Dmitry put it extremely well. And I think everybody that really starts diving into this world really starts to see that the culmination of data, being able to bring everything together. And when I say everything, I do truly mean everything geospatial, everything that has some form of location data attached to it and bringing it together. This very, very simple workflow that definitely does not do justice of the amount of work that goes into this, of the data collection, the data analysis, and then the data visualization, and the data storage, short-term and long-term. You'll notice I have the last two circled, because just like Dmitry said, just like Jake said, it's this stage that not only is the most important, but it is also the most difficult, because every technology that's out there, a drone, if they sell it, the drone can fly, the drone can take pictures, right? And most likely you'll be able to find a photogrammetry service that can stitch those photos together. But how do you then get that to, Dmitry said, 2,000 users? How do you get that to 2,000 users in an effective manner with all of the additional work that they're doing? Because those 2,000 people aren't doing the same thing, right? You're going to have your civil engineers, you're going to have your mechanical engineers, you're going to have your piping engineers, you're going to have your tank engineers, you're going to have different groups of people viewing the same data, but in a different manner. So being able to not only just visualize the data, but visualize it in an effective manner for the user themselves. A civil guy is not going to care about the technology that's not associated with their work, right? A civil guy is going to want to worry about the earthworks. He's going to worry about the concrete. He's not going to worry about the steel beam that is, part of the tanks group, right? So being able to segment out this information in a safe, or not safe, I apologize, in a simple manner for each person to be able to view, I think is extremely difficult. And in reality, pun intended, it is difficult to do that in just one solution. Dmitry or Jake, I apologize, can't remember who mentioned it earlier, started mentioning about APIs and this new world that we're coming into of open connections, open APIs that allow us to integrate into all this information. I mentioned machine control earlier, being able to pull in machine control through an API, being able to pull in all this additional information, and then being able to visualize it all in a hub. So no longer having to rely on a single technology to do it all, but a single technology that can visualize it all. And then of course, on top of that, we talk about this image capture amount. Dmitry threw out a very impressive number, and it's not going to go down, right? Technology is going to improve, and that doesn't mean we're going to capture less. That means we're going to capture more. So not only are we needing to visualize this massive and more amount of data, but we need to find locations that can store it, both short-term and long-term, because of course this data is not only valuable now, but it might be valuable 5, 10, 15 years later. So being able to use hot storage and cold storage through services that allow you to then push and pull them back and forth from your visualizer without having to re-upload, re-download, and bog down the speed of our computers. Because I do know all of us who work with three-dimensional work also have the wonderful bliss of working with a computer that doesn't quite work with the data volume that we're working with. So that's really the point I want to drive home, is that as this technology improves and as we get these amazing outputs that we want, we are creating these newer issues of how do we visualize these wonderful outputs, and then how do we store them to be used for another time.
And that really great is a great segue to the future of reality capture and where things are going. Maybe you could just again touch briefly on where you want to be from a Bechtel standpoint in just what you mentioned, kind of that higher level of collection and analysis and processing.
Yeah, certainly. Drones were the beginning of autonomy. They were the truly first robotics that we were able to get out in construction, that we could press play and it would go collect data without us really having to interfere while it was going and roaming and collecting data. Of course, what we see as we move towards the future, all of us have seen the Boston Dynamics robot dog, right? And all the variety of other robotic dogs, robotic machines, robotic tracked vehicles that are going out and being able to not only capture data, but do work. Now, of course, in this particular world, we're talking about collecting large scale three-dimensional data. So you see here an example of a robotic dog being able to carry a scanner around and a 360 imagery around, really combining all of the technologies that we see of reality capture, but now in an autonomous manner. No longer having to worry about that human aspect of the human walking out on the site. We reduce the safety issue, having to put people in these confined spaces. The example earlier by Jake was fantastic about being able to fly in a confined space without having to put people in there. Now we're able to do that with robotics on the ground as well. And so we're excited to see this higher level of autonomy collection, but then also autonomy in processing and analysis. For any of you who have worked with a point cloud before, you know how exciting it can be to have to go in and manually clean out that point cloud, and then manually identify that pipe, and then manually render that pipe into a model, and then push that model to whoever needs it. And it's so exciting to see these upgrades and movements forward in our autonomy capabilities with point clouds and with photogrammetry and AI being able to identify assets, identify pipe, automatically be able to give us our volumetric reports without us having to go in and click a button. It just goes and does it. And so that, I believe, is really the most exciting part, is moving towards this level of true autonomy, where the rover is set loose and it automatically push the data, automatically process the data, automatically analyze the data, and then whoever needs it of those 2,000, 3,000, 4,000 users can go in, see what they need, and do what they need to do. And of course, that with that higher volume of data, higher volume use, touching more people and really getting the word out and teaching people how to use this data in a good, effective manner.
Yeah, no, that's obviously a continued challenge, but Dmitry, I
Jim,
wanted to just
can I add to that, please? Yeah.
Yes,
maybe.
please.
Yeah. So it's all the same topic, but Keaton touched on several important points there. So I think autonomy, I have no doubt, right? Autonomy is the future, whether it is autonomous flying robots or autonomous roaming robots or autonomous data processing. I have no doubts one day this will happen. What I think is important, though, is that, because we are not fully autonomous today, should not stop us, as the industry from doing things, okay? Even the PenCam example, right? We didn't use expensive drones. 99% of our data captures, if not more, Jake, right, was done with basically supermarket drones, right? Phantom P4. That's all you need for many cases. We looked at dogs, right, and that kind of technology. We could not find something that could actually walk about an actual construction site. So maybe the solar farm, great. Maybe when your asset is nice, clean, done, pristine, maybe. But in the chaos kind of major construction project, we couldn't find suitable equipment. So we did a lot of scanning with mobile scanners, right, worn by people. And that kind of, another point there is that it's not about drones. It's about your requirements and your use case. We built process plants, right? There comes a moment in time when you can't see much with drones anymore because all your work moved inside, and you have to change the way you capture data so you can continue, extract those insights that you need for measuring and predicting things. So yes, I'm very strong believer in the autonomy, but it's not here yet, and that's okay.
No, and that's great. And that was kind of the next slide we had here was about artificial intelligence and machine learning. And I think I was joking before we started our session that I of course had to use an AI image there on the right, and it only took me about 8 prompts to get it to look somewhat realistic. We hear a lot of technology and AI and machine learning things that sound very good, but there's a lot of progress and things that still need to be made there. And so I know we've got about 5 minutes left here on our time, and so I did want to turn it over to Jake to maybe just talk briefly more about what as a service provider iBot has been doing to leverage sort of all this type of technology.
Yeah, thanks for that. I think that in a nutshell, well, to touch on the AI, it's a buzzword, and we think it's every time that I think that AI peaks in its hype cycle, it seems to just keep escalating. But we want to use artificial intelligence for things that just improve our processes across the board, from the capture to the processing, to the image optimization, and automatic image segmentation. Really helps us, allows us to do that. So we put in our development efforts into that, and that allows us to take artifacts that aren't important to anyone. In the instance of a project, you take out the sky, you take out the water, vegetation, and that allows for optimization of the imagery and faster turnaround times, more relevant 2D and 3D data. So those are the types of things that we're kind of leveraging. But in effect, what we've done, and I don't think that it's necessarily just our future, but the future of the the industry in general, from a service provider's perspective, it became pretty obvious what our customers' pain points were. So we just have been busy developing and automation solutions that use current technology that's tested and that works, to Dmitry's point, to address those problems. So what we did was we took a decade of our domain experience and, basically just put that technology in a box. We've leveraged the hardware and the processing that we've been using, for several years, and tested the automated workflows extensively until, really we broke them off site so that they're guaranteed to be effective on site. This solution that we've developed is able to provide the visual insight simultaneously to different teams, because we built in the flexibility that we talked about that was needed to allow for the different outputs that team members and owner operators deem valuable. And a byproduct of the flexibility of the solution allows it to be optimized for the changing needs of each project lifecycle simultaneously. So we're able to support the system from regulation to initialization to configuration, maintenance, and upgrades, and we're not overly dependent on the automation or the AI. Like we were saying, that a human being ensures the quality of the outputs, unlike a lot of these other fully automatic platforms that we have out there. But as far as the technology is concerned, it's hardware agnostic, so we can adjust for the different advancements without overhauling the entire solution and taking 2 steps back. Obviously, that the need for the visualization and how challenging that is, that we've addressed that with our own software solution. But the outputs, the multimodal outputs can be downloaded directly and integrated into the systems that are already in place. So there's very little learning curve for the end user, and there's a minimum human behavior adaptation. And both of those things are driving adoption, of solutions like this. And once we are able to configure it to meet the data standards of an organization, then an autonomous solution, the scale of that quickly becomes financially justifiable because the solution's remotely operated, and it allows for the integrations into the central systems, but it doesn't depend on them to create valuable data. And the solutions like this we talked about in the survey, that things that we're having to be careful about were budget and domain expertise. So the whole solution based on this is there's no hardware that's included. It's a subscription model. So one can easily justify the deployment of the system like this by against metrics like reducing travel, workforce optimization, progress transparency, and so on and so on. But living in the drone space for a decade or more, it gives me a degree of confidence about where the industry's headed. Like I said, it's not really just iBot's future. We feel like unarguably it's the future of the project and the asset management. So you take that for what it's worth, but thanks for letting me share.
Yeah, and so I do see we had some questions come in. Thank you, Dmitry and Keaton, for trying to respond. And I do apologize to everyone if we didn't get a chance to get to your question. I know we're sort of up against our time here, and I realize everyone's quite busy. And I want to just again thank you all for taking the time to attend today. If you have a chance watching this on the recording, thank you as well. So I especially want to thank our panelists for taking time out of their days to be here and share with us. And maybe we can get together again sometime soon and expand upon some more value and uses around reality capture. So